everyone, we are from Group 7. Today, we are diving into the fascinating world of full-wave rectifier. We are going to detect the circuit to convert AC to DC. Well, that's exactly, what full-wave rectifier do. First, we are going to full-wave rectifier. Let's understand what a rectifier is. A rectifier is an electrical device that converts AC current to DC current. It's essential in many electronic devices that require a steady DC power supply. The simplest form of rectification is half-wave rectification, where only one half of the input AC circuit is converted to DC. But there's more efficient way, full-wave rectification. Full-wave rectification utilizes both the positive and negative circuit of the input AC voltage, resulting in a smoother DC output. There are two main types, the bridge rectifier and the certain tap rectifier. In the certain tap rectifier, a transformer with a certain tap is used. During the positive half circle, one diode conduct, allowing current to flow through the load resistor. During the negative half circle, the other diode conduct, again maintaining the current flow in the same direction. Well, the bridge rectifier configuration use 4 diodes arranged in a bridge-like configuration. During the positive half circle, diodes D1 and D3 conduct, allowing current to flow through the load resistor. During the negative half circle, diodes D2 and D4 conduct, maintaining the current flow in the same direction.
For the full wave bridge rectifier with the filter, a capacitor filter is added to the wave bridge rectifier circuit to reduce the ripple voltage and rectify output waveform. To achieve this, a 10 new F capacitor is placed across the 1K ohms load resistor. While the full wave bridge rectifier converts AC to DC, the output voltage may still contain the ripples. To smooth out this ripple and obtain the most stable DC voltage, we can add a filter capacitor across the output terminal. The filter capacitor charges during the periods of high voltage and discharge during the period of low voltage, effectively reduce the ripple. With the addition of the filter capacitor, the output voltage across the load resistor becomes smoother and more constant. To resembling the cleaner DC voltage, the capacitor acts as the reservoir, storing the charge during the peaks of the rectified waveform and supplying it during the trough and resulting in more stable output voltage. When the AC voltage is rectified, the result is a passing DC waveform that varies in the voltage over time. In this circuit, the capacitor stores the electrical charge during the period of high voltage and discharge during the period of low voltage. As the rectified waveform passes through the capacitor charges up during the peak of the waveform and fills in the gap between the peak when the voltage drops when it discharges.
So basically, the full wave bridge rectifier with voltage regulator. Voltage regulator are electronic devices that maintain a constant output voltage despite changes in input voltage or load conditions. They are essential in many electronic applications where a stable DC power supply is required. The voltage regulator, which is Zener diode, is added to the circuit. Zener diodes prevent much fluctuation in the output voltage due to the variation in input voltage or load resistance. During rectification, the full-wave bridge rectifier comprising 4 diodes converts the input AC into DC voltage. To further refine the pulsating DC voltage produced by the rectifier, filter capacitor is introduced across the output terminals. This capacitor serves to diminish the ripple voltage, leading to a more consistent DC output voltage. Within this setup, the load resistor functions as the electrical load linked to the rectifier circuit output. Each symbolized device necessitating a steady DC voltage supply. To achieve a constant DC output voltage, a Zener diode is connected parallel to the load resistor. The Zener diode maintains an almost constant voltage across itself, ensuring stability in the output voltage. Any surplus voltage beyond the Zener diode breaks down voltage is diverted through the diode, regulating the output voltage. Overall, integrating the Zener diode into the circuit result in a relatively smooth pulsating DC waveform with reduced ripple voltage, as depicted by the oscilloscope, offering a more stable output compared to a basic rectifier circuit in earlier step. Okay, so thank you. That's all from our group.